Today I'm going to do a quick start guide to significant figures. So I'm going to talk about all of the rules for significant figures and then talk a little bit about some examples and what we might see. There are going to be 4 rules that we'll go over. Our first one is that any non-zero number is going to be considered significant. So 1 through 9, all of those are going to be considered significant. If you see that in a number, you can count that as one of your significant figures. Our other 3 rules have to do with our zeros. So let's start at the zeros at the front. If we have a number like 0.1, this 0 right here does not count as a significant figure, but this 1 does. So our 1 goes to rule 1. Any non-zero number is significant. That one's going to be significant. But the 0 at the front, sometimes these are called leading zeros. These are not going to be significant. This number right here has a 1 significant figure, or 1 sig fig for short. Now our third rule is any 0 in the middle of 2 non-zero numbers is significant. These are sometimes called sandwich zeros because they're sandwiched in between 2 non-zero numbers. If we have 202, we always start left to right. Our 2 is a non-zero number, so this is definitely significant. We now come across this 0 right here, and we need to see if that is sandwiched in between 2 non-zero numbers, so we're going to look ahead a little bit. We see another non-zero number, in this case another 2, which makes this 0 significant. This number right here has 3 significant figures, or 3 sig figs. And then finally our fourth rule, which you might be able to guess, we talked about the zeros at the front, the zeros in the middle. Our last one is about zeros at the end, and this is not such a clear-cut rule as the other ones. A 0 at the end is only significant if there is a decimal point somewhere in the number. So let's look at 2 examples. We're going to look at 100 versus 1.00. Now I'm going to give you a hint for these. These 2 numbers, while they have all of the same numbers in them, do not have the same number of significant figures. These 2 numbers do not have the same precision as a measured number. So let's look at these. Let's put some units on them. Let's say we're talking about 100 meters versus 1.00 meters. These have been measured with instruments that have different precision if this is how they are written. Now, for our 100, there is no decimal place anywhere in this number, which means the only significant figure is this 1. These zeros at the end are not significant because there is no decimal point. This has 1 sig fig. Now over here to the 1.00 meters, our 1 of course is always significant. We don't need to worry about any non-zero number. These 2 zeros at the end do become significant, and that is because there is a decimal point right there. Now in this case, this one has 3 sig figs. Now, those are our rules for determining significant figures. We are going to do some examples with just a couple of different numbers to decide how many significant figures there are. I have 4 different numbers written on this slide. I have 0.0013, 1008, 27.0, and 3600. What we're going to do is we are going to determine how many significant figures are in each of these numbers. Now for our 0.0013, what we do is we read from left to right. In this case, this one has leading 0, so if we start with a 0, we know that that's not going to be significant. And we keep going, none of these zeros are significant at the front. Then we hit a 1, any non-zero number is always considered significant, and we have a 3, which means another significant figure. In this case, we have 2 sig figs for this number. Now let's go to the 1008. We're going to start left to right, and we see a 1. We know automatically that is a significant figure. And then we see a 0. Now we need to decide, is this a 0 that's at the end, or is this sandwiched between another non-zero number? So we're going to peek at the end, and we do see an 8 right here. And that 8 means that both of these zeros are significant for 4 total sig figs. We're going to look at this 27.0. We have a 2, that's significant, a 7, that's significant, and now we have a 0 at the end. The zeros at the end do require a decimal point to be significant, which we see right there. This is significant. This one has 3 sig figs. And then finally we have 3,600. This also has some zeros at the end. We have a 3 and a 6, which any non-zero number is always significant. And then 2 zeros at the end, but there is no decimal place anywhere in this number. So these are not significant. This number only has 2 sig figs. Now, in these cases, we can apply our 4 rules. Let's look at some tricky examples where it might not be as clear-cut what's going on with the sig figs. For these, I have 2 numbers, 100 meters and 1.5 times 10 to the minus third. So let's look at how many significant figures these are, and I'm going to talk about why it's a little bit tricky. For this 100 meters, you'll notice that there is a decimal point. And this isn't a typo. I put this in intentionally because sometimes we want to show a number that ends in a 0 that 0 is actually significant. And so in this case, this 100 with that decimal point means that this has 3 sig figs. We know that if it ends in a 0, then they might not be significant. It depends on if there's a decimal point, and in this case, that decimal point at the end makes those significant. In the case of if we just had 100 meters, well, then that would be 1 sig fig. For the 1.50 times 10 to the minus third, sometimes it gets a little bit tricky when we're looking at scientific notation or when we're looking at decimals. Now, in this case, when we're looking at the 1.50, we can use this to determine our significant figures. You don't necessarily need to convert it, but I'm going to just so we can see what this actually looks like. So what we're doing when we're converting from 10 to the minus 3, we're going to move this decimal place 3 spots. So 1, 2, 3. And in this case, we get 0.00150. Now, what we have here is the 1, the 5 are significant. I'll underline these. And then because there is a decimal place, this last 0 is also significant. So this number also has 3 sig figs. We can use our scientific notation to also determine our sig figs and determine our precision. It's written in a way that we can use that first factor. In this case, I've put a couple of practice problems here with some things that we might see as we're going through and doing math, especially in chemistry. For significant figures, those rules that we learned are going to be really important when we're doing multiplication and division. I'll talk about in a moment what we'll do with addition and subtraction. If we get 3.60 and type it into our calculator and multiply it by 1.2, what we would get is 4.32, and then we have meters times meters, so meters squared. But this is not quite our correct answer yet. We need to look at the number of significant figures in each measured number that we're using. In this case, the 3.60 has 3 sig figs, which I'm going to abbreviate SF just for space. Our 1.2 has 2 sig figs, the 1 and the 2. When we are calculating from measured numbers to measured numbers or even more, we can only have the same precision as the least precise number we use to calculate. In this case, our least precise number is the 1.2. That only has 2 significant figures, which means we need to round this 4.32 to 2 significant figures. We start left to right. We're going to keep the 4, that's significant, and we're going to keep this 3. Everything else we're going to throw out, but we do need to take a peek over at our first number that we throw out, in this case the 2. If this number is 5 or above, we round up. Otherwise, we round down. So our real answer to this is 4.3 meters squared. This would be our final answer, because this conveys the precision that our measured numbers allow us to have in our answer. For our next one, we have 4.2 centimeters divided by 2. In this case, we could pop this into our calculator and what we would get is 2.1. Now we need to check our precision. For our significant figures, we have 4.2, that's 2 sig figs. And then our 2 right here actually only has 1 significant figure. We're going to do the same thing and round our 2.1. Just like before, we're going to cut it off so that we have 1 significant figure. We look at our 1, which we're throwing away, and in this case, we're going to round down and keep it at 2. That would be our answer to that particular problem. Now, with multiplication and division, we use our significant figures, but let's look at what we do with addition and subtraction. We don't use those same rules. We go off the number of places after the decimal point. There's a couple of ways that textbooks write this, but essentially we're looking at where the decimal place is and seeing how many places there are, how many numbers are after that decimal place. If there is no decimal place, then technically that has 0 places after the decimal. There's no decimal place, so there's no places after. But let's look at our first one. We have 1.25 grams plus 2.5 grams. Again, if we typed this into our calculator, what we would get would be 3.75 grams. Now this is addition and subtraction, so we are not looking at significant figures. We are looking at places after the decimal. For 1.25, we have 2 places after the decimal. Let me clean up those lines. 2 places after the decimal. For the 2.5, there is only 1 spot after the decimal. Now the reason we do this is because our last number to the right is the one that we consider the one that we are approximating or estimating. Essentially, when we have a tool or instrument that we're using to measure something, that last number is the one that is not right on, if it's a ruler, right on the notch. So in this case, we have 2 places after the decimal and 1. We go off the least. So in this case, it's 1 place after the decimal. We're going to keep the 7. Just like before, we're going to look over here to see if we round. Now in this case, it's a 5. So we are going to round this to 3.8 grams. Our next one, we have 3.5 centimeters minus 1.00 centimeters. If we popped this into our calculator, it would probably actually give us 2.5 centimeters. That's what it'll give us if we put this in. Now, in this case, we're going to check. We have 1 spot after the decimal. We have 2 spots after the decimal. We're going to keep 1 again, but that's actually what we have written right here. There is sort of our calculator not giving us any extra zeros. So our calculator isn't going to give us sig figs. It's not going to add any zeros at the end or anything like that. So this is our correct answer. Our calculator would actually give us the correct one for that one. So this is a little bit of an overview of how we deal with precision in chemistry, and this also works for many other different sciences. But for addition and subtraction, we're looking at places after the decimal, and then for multiplication and division, we use all of our significant figure rules.